Keith-Magee, and I'm here today to show you how you can write a data visualization app for your phone using nothing but Python. Before I start, I'd like to acknowledge that I'm speaking to you today from Wajik Noongar Budja, otherwise known as Perth, Western Australia, and I'd like to recognise the Wajik Noongar as the traditional owners of this land, to recognise their continuing connection to these lands, waters and culture, and to pay my respects to their elders past, present and emerging. A little bit about me. I am a principal engineer in the open source group at Anaconda. Anaconda supports the Python open source ecosystem by providing direct financial support to organizations like NumFOCUS and by employing developers to work full-time on open source projects like Jupyter and Number, and the open source project that I founded, Beware. For those that haven't come across it before, Beware is not a single product or library or tool. It is a collection of open source tools and libraries for creating native user interfaces in Python for desktop, but also for iOS, for Android, for single-page web apps and console apps. Each tool in the suite solves one very specific part of the overall problem of writing a GUI app in Python and distributing that app to other people on various platforms. Anaconda supports Beware to ensure that Python remains a viable programming language on the platforms that people are increasingly using as part of their day-to-day computing life, phones, tablets, and so on. However, it is important to note that Beware is not an Anaconda product or anything like that. It is a fully open source project with independent governance and funding. I just happen to be paid by Anaconda to work on it full-time. And so today we're going to look at the Beware suite of tools and how you can use those tools to deploy the Python data science and visualization libraries that you're probably already familiar with to deploy an iOS and an Android app from a single Python codebase. This is going to involve two major pieces of the Beware suite. The first is Toga. Toga is Beware's cross-platform GUI toolkit. It lets you use a single code base to write a GUI application that can target multiple platforms. And on each of those platforms, you get a native user interface. So on macOS, it will look like a macOS app. On iOS, it will look like an iOS app, and so on. It isn't just a cosmetic appearance either. The apps are native. Toga abstracts the native system widgets and capabilities, providing a common Pythonic API to build apps. This also means you inherit all the native capabilities of those platforms. So, for example, accessibility affordances like screen readers and adaptive font sizes just work. The second piece of Beware we're going to use is Briefcase. Briefcase is a tool for packaging Python applications. It takes your Python code, wraps it up as a standalone unit that can be given to an end user with no Python experience at all, so they can install it on their device of choice without ever knowing that they're running Python code. In our case, we're going to use Briefcase to prepare an iOS and Android app that could be submitted to those platforms' respective app stores. Now, while it obviously pairs very well with Toga, Briefcase is not Beware or Toga specific. You can use Briefcase to deploy a Pygame app if you wanted to. Briefcase can't magically make Pygame work on Android, but to the extent that a GUI library supports a platform, Toga can support deploying it to that platform. All right, so let's dive right in. Let's write an app and then deploy it to iOS and Android. For demo purposes, I'm going to keep it reasonably simple, but not completely trivial. We want to be able to use the Python data science libraries we're familiar with. So let's use NumPy to generate a random series of data and then use matplotlib to build a histogram of that data series. One of the benefits of using an app is that you want users to be able to interact with the data. So let's make sure that's possible. We'll use a couple of sliders to control the mean and standard deviation of the random data, and we'll provide a button to just generate completely new random data with the same mean and standard deviation. And we want to show that this is cross-platform. So we'll deploy it to both iOS and Android from the same source code base with no modifications. So where do we start? Well, Briefcase has a wizard you can use to bootstrap a new app. So create a new virtual environment and install Briefcase, pip install Briefcase. With Briefcase installed, you can then run the wizard to start a new project. You run Briefcase new and you'll be presented with a list of questions with explanatory text. You'll be prompted for a formal name. It's the name of the app you show to humans, and an app name, a Pythonized version of the name, something you would pip install. So let's use PyData demo for this new app. You'll be asked for a bundle. This is used for namespacing to separate my PyData demo from your PyData demo. This is a common format that's used by app stores. It's usually a reversed ordering of a domain name that you control. So in my case, org.beware. That bundle is then combined with the app name to make a full bundle ID for your app, org.beware.pydatademo. you'll be asked for a project name. A briefcase project can include multiple distributed apps. In this case, we'll just default to the app's formal name. We'll be asked for a one-line description of your project, for an author's name and email that's used in help text and copyright labels. You'll be asked for a URL for the project, a license, and lastly, a GUI framework. We're going to use Toga for this example, but there are also templates for PySide, Pursuit PyBear, Pygame, or you can select an empty project with no GUI toolkit at all. When you complete the wizard, Briefcase can generate that app and it will give you instructions on how to run the project. So let's follow those instructions. We cd PyData demo and run Briefcase dev. Briefcase includes a developer mode, which lets you rapidly iterate on your app and its configuration. When you run Briefcase dev, Briefcase looks at the project's configuration, works out how to run the project in your local virtual environment. The first time you do this, it'll install some dependencies based upon what your template generated, and then it will start your app. For what it's worth, Briefcase dev is really not that much more than a convenient shorthand for pip install followed by Python -m PyData demo with a couple of debug flags turned on and some environment stuff set up. And if all you've got is the content generated by your wizard, at this point, what you'll see is a working app. It will be an empty window, but it will be a fully working native app, in this case on macOS. Let's take a closer look at what was generated for us by the wizard. If you look into the PyData demo folder that's been generated, you'll find the code for the app, application icons in variety formats, and project metadata. You'll get the same files regardless of which GUI framework you pick. The only difference will be the contents of app.py, donedomain.py, and some of the values in pyproject.toml and readme and the license file. Let's take a look at those files and see what's in there. pyproject.toml is the configuration file for your project. The contents of this file will match the answers that you gave in the wizard. All the briefcase options are defined in a tool.briefcase section and subsections of this configuration file. The top level project and author identification is all in just a straight tool.briefcase. Individual apps are then defined in their own sections. So this configuration section just defines a PyData demo app, that's the app name, with a formal name of PyData demo, and so on. At runtime, the configuration for the PyData demo app is composed from the project settings overridden by the app settings. So even though there isn't an author name defined here in this app config, it will inherit one from the project level definition on the previous slide. If you wanted to have a different author name for this app in your project, you could do so by including an author name in the app's configuration block. Now, I said that the app settings override project settings. There are 4 exceptions to this override behavior: sources, requires, test sources, and test requires. Sources defines the list of directories of source code that you want to include in your app. Here we're saying source PyData demo directory. Any code or resources in that folder will be copied into your app. It's a list, so if you specify multiple sources, they'll all be copied. The only requirement is that one of your source directories needs to match the name of your app, so PyData demo in this case. Requires defines the Python requirements for your app, again, as a list using the same format you'd use as an argument to pip install. So a bare package name, a package with a version specifier, a Git repository, or a path to a local folder that contains an installable package. They're all valid options here. Test sources and test requires are the same as sources and requires, but they define code that will only be included when you're running the app in test mode. These 4 settings are cumulative settings. So if you specify a sources definition at the project level, any app level sources will be appended to the list defined at the project level. Why does this matter? Well, you can also specify options that are platform specific by adding a configuration section for that platform. The generated pyproject.toml will include a section for all the supported platforms: macOS, Linux, Windows, iOS, Android, and web. So here we've got specification for iOS and Android of our PyData demo app. These options will only apply to the builds of the app on those platforms. Sources, requires, test sources, and test requires are cumulative, so any deployment on iOS will install the app level requirements from the previous slide, but also will install Toga iOS and standard NSLog. A deployment on Android will have the same app level requirements, but won't have Toga iOS or standard NSLog. They'll have Toga Android instead. All the other settings will override app level and project level values. So you could have an iOS specific author name, for example. That's the project configuration. What about the app itself? Well, the logic for the app is all contained in app.py. At the moment, it's a bare stub. It declares a class called PyData demo, which is a subclass of toga.app, and that class has a startup method. That method creates a box. That's Toga's representation of a generic container of content. It creates a main window and sets the content of the main window to be our empty box, and then it shows that main window. The main method for the app just creates an instance of that class, and the briefcase process will start that main method. That's all the code we need to generate the empty app that we saw previously. So let's bulk this out a little bit now with a real app. Let's replace the content of our startup method. We start with a main window, same as before. Now we want to draw a chart. We're going to use Toga chart, which is a matplotlib backend that can render natively to Toga. So we create an instance of this, instance of a chart widget from Toga chart. Two details in the constructor for this chart widget. Toga lets you set the style of each widget using a subset of CSS called pack. So we tell Toga here that we want the widget to be flexible. We want it to expand into any available space. And we set an onDraw handler. Now, whenever the chart needs to draw itself, it will invoke a method on the app called drawChart. This is an event handler. It can be a bare function, a method on a class, or an asynchronous coroutine. And we'll define this method a little bit later on. Continuing our startup method, we also want some sliders to control our random data. So let's create a slider called mu to control the mean of our generated data. It's going to have an initial value of 100, but it can range from 0 to 200. It also has an event handler on change. So whenever the value of the slider changes, we want to invoke recreate data. Again, we'll come back to that one in a bit. When we put the slider on the screen, we're going to want to have a label next to it. We want the label to be beside the widget. So let's create a box whose children are a label with a mu and the mu widget that we just created. By default, boxes are laid out horizontally the same way as they are in HTML. And we'll also modify the style, saying that we want the slider to expand size if it can. We'll add some padding around the widgets in this box, 5 pixels top and bottom, 10 on the left and right. That's the same syntax it's used for CSS padding. Now, that's the mu slider. We also want to change the standard deviation. So let's set up a second slider called sigma. That's almost the same as the mu slider, except that instead of an initial value of 100 and a min-max of 0 and 200, we're going to have an initial value of 15 and a range from 1 to 30. Also, notice here that the slider widget has been assigned to self.sigma. So it's a property of the app that we're building. But the box is just a bare Sigma box, and the label isn't assigned to anything at all. That's because we're going to need to access the value of the slider throughout the app, whereas the box only needs to be referred to later in the startup process as part of sort of the construction of building things. And the label doesn't need to be referred to at all. It just needs to be put in the box. We also want to be able to regenerate data, so we'll create a button. We need to set the text of the button, so we'll have a recreate data label on the button. And when the button is pressed, we need to handle that event. So we'll have an onPress event handler that invokes the same recreate data event handler we've used for the two sliders. After all, it doesn't matter if we change the mean, standard deviation, or just want new data, we're going to need to redraw the chart. We'll also give the button some padding as well. Now we can start to put all the pieces together. Before we draw the chart for the first time, we're going to need to have some initial data for the chart being drawn. So we'll wrap that up in a set data method. We'll come back to that in a minute as well. We can set the content of our main window. Our main window will consist of a box that contains a chart, the box with a mean slider and label, the box with a standard deviation slider and label, and the regenerate button. Now, by default, boxes lay their content out horizontally, but we want these 4 widgets to be laid out vertically, so we'll set the style of the main content box so that it's a column box. And that's our startup method. So now we can fill in some of the gaps that I referred to along the way. We need to have a set data method to define a data series. That's easy enough. We use NumPy to generate a series of 1,000 random numbers on a normal distribution, multiply the value by the sigma slider to give a distribution, some spread, and then add the value of the mu slider to set the mean. We then store the result as the X attribute of the app so we can access it anywhere we need to. All right. We also need an event handler for when the data is recreated. Whenever either of the sliders change or the button is pressed, we need to regenerate the data. So we call set data, and then we tell the chart to redraw itself. Just a manual, hey, go redraw. As recreate data is an event handler, the first argument to that handler is the widget that generated the event. In our case, we don't actually care which widget generated the event, but if we did care, the detail is there for us to use. Lastly, we need to actually draw the chart. This is also an event handler. When the redraw is triggered, either because the window is resized or because redraw has been directly requested, this is the handler that gets invoked. As it's an event handler, the first argument is the widget that generated the event, the chart, but it also gets a figure argument, which is a literal matplotlib figure instance. And so we can draw on that figure using any matplotlib API you want to. So let's add a subplot, generate a histogram with 50 buckets in the same range as our new slider, 0 to 200, label our axes, and set the figure to have a type layout. And that's it. We've got a demo app that draws a chart. Okay, but before we deploy to our phone, let's just use development mode to actually just check that everything's working. So we can run briefcase dev and, oh, it's going to crash because it can't find NumPy. Well, that's embarrassing. We're using NumPy in our project, but we haven't installed NumPy. So let's modify our project to declare our dependencies. Let's go back to our pyproject.toml. The app section declares our requirements. So we need both a NumPy and TogaChart as dependencies. TogaChart specifies a dependency on matplotlib, so that'll be installed transitively as well. So save those changes. Now run briefcase dev -r. The extra -r is needed because our requirements have changed. So that will go through and say, okay, well, let's have a look at the requirements and install them all. We'll install NumPy, TogaChart, all the requirements of those packages, and then you see an app with a chart, 2 sliders, and a button. If you press the button, you get a fresh sample of 1,000 data points. If you move the sliders, the chart will update itself to modify the mean and the standard deviation. Okay, so we've got our app running in development mode. Let's get it on our phone. First step, we need to create our app. Let's target iOS first. So we invoke briefcase create iOS. This will do a bunch of things. First, it will check that you have Xcode installed. If you don't, it'll direct you to the App Store and give you a download link. If it is installed, Briefcase will get an application template for the platform. This is a code template providing all the scaffolding and project files needed to support a Python app on iOS. Then you will obtain a support package. Support package is a pre-compiled version of Python that can be embedded into your app. Briefcase downloads the support package, unpacks it into the application template that was just unrolled. Then Briefcase installs your application code, anything declared in the sources section of your project. It then downloads and installs all of your app's requirements. It doesn't install them into your local virtual environment, though, and doesn't use anything in your local virtual environment. It installs them into the application template as a standalone environment. We are building an app for distribution, so we can't rely on anything that is on my local machine, my local virtual environment. Also, we need binaries that will work on iOS, so our local installed versions of NumPy and Matplotlib wouldn't work on a phone anyway. Then Briefcase installs any application resources like icons, it purges any content that isn't needed, and it's done. You've now got a complete application template. For iOS, that essentially means a full Xcode project. You don't need to touch anything in that project, though. It's there in the build folder, but you don't need to do anything to it. The next step is to build the app. To do that, Briefcase build iOS. This will literally compile the Xcode project that was just generated. Again, you don't have to open the Xcode project, write any Objective-C code or Swift code. You just need to run Briefcase build iOS, and that will compile it. Now, this can be a little noisy on the console. If you run this today, you will get a bunch of warnings about capability item models not being defined. These warnings can be ignored. It's actually a bug in Xcode. Briefcase is constantly playing whack-a-mole, hiding Xcode warnings that you can safely ignore. The build will take maybe a minute. It needs to process all the binary modules in the standard library, all the binary modules on your dependencies, assign them, package the app into a bundle that can be sent to a phone. And once it's compiled, you can run it. Briefcase run iOS will run the app on the iOS simulator on your laptop. If you do just a straight Briefcase run iOS, you'll be asked what simulator you want to run on. Do you want an iPhone SE or an iPhone 15 Pro Max or an iPad? Your pick. When you do make your selection, Briefcase will tell you the syntax to shortcut that question next time and specify the device directly from the command line. You can't deploy to an iOS device directly from the command line yet, but you can using another command that I'll mention in a moment. And what you'll see is a running app. Functionally, it'll be identical to what you saw from Briefcase Dev, but with a couple of distinct differences. Obviously, it's phone-shaped, but also the widgets are now iOS-specific widgets. The slider and the button are iOS-style buttons and sliders. And if you turn your phone on its side, it will respond to the aspect change. The widgets that were marked as flexible will resize of the axes you ask them to be flexible. Okay, so we've successfully run our app on the iOS simulator. Can you run it on Android as well? Well, yes, you just go through the same process, replacing iOS with Android. There's 3 very slight differences though. Firstly, if Android Studio isn't installed, Briefcase can manage the download process for you. It takes about 10 minutes to, on my machine anyway, to download the whole of Android Studio, but it will just manage it. You don't have to go through through an app store. Secondly, Android Studio doesn't ship with any default devices, so you'll be prompted to create an emulator device. But Briefcase will walk you through that wizard, through a wizard to manage that process. And once you've created an emulator once, you could use the same emulator for any Android project down the line. Third, as on iOS, you can, if you just say run Android, when you get to the run step, you'll be prompted to choose a device to run on. However, Android will let you deploy directly to a physical device. If you plug your phone in by USB cable, it will appear as a target where Briefcase can deploy. You do need to do a little bit of configuration to make this work. You need to turn on USB debugging on your device, and then there's a weird dance you need to do to enable the developer mode. But again, Briefcase will walk you through, or do what it can to walk you through that process. And again, you get a running app, this time in the Android emulator. Okay, so we've created, built, and run our app on both iOS and Android. Then you want to make a change. Do we need to go through this whole create, build, run process again? Well, you can, or you can just use Briefcase Update. By default, this will reinstall the code for the app. If you want to update requirements as well, say we updated a dependency on pandas, or we added a dependency on pandas, you can specify -r. If you want to update application resources like icons, you can specify -- update resources. Some other features that are worthy of note. We have been demonstrating iOS and Android here, but Briefcase can also be used to deploy to macOS, Windows, and Linux desktops. The apps that are generated are completely standalone. What you get out of the build process is an MSI installer or a macOS DMG or a Linux deb or RPM package. You can take that bundle and give it to anyone, and the app will just start. You don't need to teach them how to install Python, how to create a virtual environment, or so on. You just give them a download link, they download the app, they double-click on it, and the app starts. If you don't specify a platform, Briefcase will default to building an app for your current platform. So I'm on a Mac laptop, a bare Briefcase will create a macOS app. Some platforms also have multiple output formats, so you can produce a Flatpak on Linux, for example. Briefcase will also imply earlier steps if they're needed. If you have a fresh project straight out of Briefcase New and you go straight to Briefcase Run, Briefcase will detect there isn't a template yet and create it and then build it and then run it. Briefcase Run also allows for a -u option, so that which will update the app before execution. So, your development process could be just Briefcase Run -u over and over and over again. Briefcase Open is another command that's handy. It will open your project. On Android, that's just a file manager on the folder that contains your Android Gradle project. But on iOS, it will open your app in Xcode. When you are ready to run your app on a physical device or to submit your app to the App Store, that's what you'll have to do. I haven't got time to go through that process today, but the Briefcase documentation does walk you through it. The demo app here we've used is using NumPy and Matplotlib. What about other third-party packages? Well, it depends. If the package you want to use and its dependencies are pure Python, you can just use it. Put it in your requires list, Briefcase updates -r, you're done. The only place it falls down is if that package has if sys.platform equals something logic in it, in which case you might need to patch it to add iOS or Android support. Anything with binary modules, that's a little bit more complicated. On desktop, binary wheels just work. They're pip installed, distributed without any difficulty. On mobile, binary wheels just work too, but most projects don't publish binary wheels for iOS and Android, if only because they can't be uploaded to PyPI. In fact, Beware is the only group currently building binary wheels for iOS and Android. We maintain an independent pip-compatible repository where they're stored, and Briefcase uses those repositories. If the package you want isn't on that the list that Briefcase provides, or is on the list that Briefcase provides, you're fine. If it isn't, building can be complicated depending upon the package. We've got many of the more common packages, NumPy, Pandas, Pillow, some older versions of cryptography, but we're a small team and rebuilding the universe takes some time. We have documented the process of adding a build recipe, but some packages are just harder than others. Unfortunately, SciPy and OpenCV are two commonly requested packages that aren't available on iOS at the moment because they need a Fortran compiler, and there isn't a Fortran compiler for iOS. This is something that we are working on and looking at. Speaking of future work, what's coming in the future? Well, permissions are a big item on our to-do list. These are most significant on mobile, where you need to ask for specific permissions to access the camera or access geolocation services. These permissions are becoming increasingly common on desktop as well. Speaking of integration with device sensors, right now, Beware doesn't have any cross-platform APIs for accessing device sensors like cameras and accelerometers. You can use those sensors. You just need to call the native platform APIs, so native Android, native iOS APIs over the language bridges that Beware provides, using the same language bridges that Toga uses to access the native widgets. It's entirely possible, does require a little bit of expertise and sort of reading some strange documentation. Strange in terms of alien platform documentation. We've also begun the process of getting iOS to official Tier 3 support in Python. PEP 730 was accepted earlier this week by the Steering Council. The first patches have already landed to add that iOS support. See the PEP for details. We're hoping to start the same process for Android in the very near future. This should unlock allowing binary modules for mobile to be uploaded onto PyPI. And that's Beware. If you do nothing else, I recommend going through the Beware tutorial, docs.beware.org. Beware has a Briefcase, has plenty of configuration options and other details I haven't gone into, though. If you do want to know more, Briefcase's documentation is fairly thorough. I've also only just touched on the very surface of Toga. Toga's documentation contains a lot more details, and the Toga GitHub repository has a lot of example code. And the code for today's demo is largely the same as the example project in the Toga chart repository. If you like what you've seen here, or you'd like to support this work on Briefcase and the Beware project, you can join the project as a financial member. You can also back me on GitHub sponsors. Or if work in kind is more your thing, we're also always looking for new contributors. We have a long list of features we'd like to add. We have challenge coins for people who contribute. We'd love to see people come up and help. Thank you all very much.
Thank you. I can see a question on the chat. Which is about Plotly. Is that something that is?
Sorry, I'm trying to see the question here.
Yes. So, what about Plotly? Do you have you tried mobile app with Plotly?
I have not tried Plotly directly. Good question. I don't know is the short answer. The way to find out is does Plotly have a Py3 any none wheel, or is it a binary wheel? If it's a binary wheel, something will need to be compiled. If it's just a pure Python wheel, then you likely can just straight up use it.